Hello everyone. As we prepare for the AP exam coming up in a few weeks, I wanted to spend a little bit of time on some major topics, and the one I have chosen for this set of videos has to do with position, velocity, and acceleration. And these problems are from section 3.4 in your book. So if you want to reference section 3.4, that might be helpful in terms of some of the definitions and some of the relationships. But these are problems that we've looked at before, but I think it's worth reviewing because of velocity, position, and acceleration show up so frequently. In number 9, we are given a velocity time graph here, and it says that the accompanying figure shows the velocity of a particle moving on a coordinate line. And then it asks us, when does the particle move forward? Now, the particle will be moving forward whenever the velocity is positive. So, in the first part, where is the velocity positive? Well, at 0, the velocity is positive. So I'm going to say that from t is including 0 because at 0 the velocity is already positive. But we're only going to take that up to right before 1 because at 1 the velocity is not positive anymore. So the velocity is when is the particle moving forward? From 0 to 1, and then also from 5 to 7. Now, when does it move backward? Well, it's going to move backward whenever the velocity is negative. So that would be from 1 to 5. Okay, from 1 to 5. Now, it says, when does it speed up? Now, whenever it's speeding up, that's when the velocity and the acceleration have the same sign. Now, what we're looking for then is when is the velocity positive and also the acceleration positive. And remember that the acceleration is the slope of the velocity graph. So in this part of the graph, the velocity is positive, but the acceleration is negative. Therefore, it will be slowing down from 0 to 1. Now, from 1 to 2, the velocity is negative, and the acceleration is also negative. So it would be speeding up from 1 to 2. Now, from 2 to 3, the velocity is negative, but the acceleration is 0. From 3 to 5, the velocity is negative and the acceleration is positive. So it's going to be slowing down. From 5 to 6, the velocity is positive, acceleration is positive. So it's going to be speeding up from 5 to 6. And then from 6 to 7, the velocity is positive. Okay, it's taking on positive values, but the slope is negative. So it would be slowing down. Now, when does the particle move when is the particle's acceleration positive? Okay, we went through that here. When is it negative? Then when is it 0? Now, when does the particle move at its greatest speed? Now, remember that speed is the absolute value of the velocity. Okay, and so at the greatest speed, in terms of this problem, the greatest speed is where it is furthest away from 0, okay, where the velocity is the furthest away from 0. So very negative here, very positive here. And if we drew a dotted line here, it looks as though this distance is the same distance as the distance above here. So the greatest speed would be at 0 or between 2 and 3. So from 0 and then also from 2 to 3. Now, when does the particle stand still for more than 1 instant? Okay, it's going to be standing still for more than 1 instant when the velocity is 0. And here, that would be from 7 to 9. Okay, from 7 to 9. Okay.